A rock is thrown horizontally with a speed of 10 meters per second from a cliff that is 20 meters high. Determine the time it takes to hit the ground below and how far from the base of the cliff does the rock land. You'll note that this problem is the same height as the previous problem, but now we have a horizontal velocity. So we're going to do this the same exact way. So we're first going to set a reference frame right at the rock. And then we're going to write our knowns and then what we're trying to find. So we know the initial height is 0 meters, our initial x position is 0 meters, our initial velocity in the y is 0 meters per second, our initial velocity in the x is 10 meters per second, and then we know our final y is negative 20 meters, and we are trying to find x and time. So to do this, what we're going to do is we're first going to find the time. And we can do that the same exact way we did in the previous problem by using the second kinematic equation in the y. So we get y equals our initial height plus our initial y times time minus 4.9 t squared. And again, y naught is 0 and vy naught is 0. So you're going to see that we get this same exact equation. So we can solve for time the same exact way, and we get t squared equals y divided by negative 4.9, and then we can find time as the square root of y over negative 4.9, and if we plug in y, we get negative 20 over negative 4.9, and we get 2.2 seconds again. So we see that the horizontal velocity has no impact on the time it takes for this object to fall from this height. So now all we have to do is use the time and the x equation. We only have one x kinematic equation, which is x equals x naught plus v x naught t. And we know that the initial x position is 0, so we can just plug in x is equal to vx naught t, which we know is 10 meters per second times 2.02 seconds, which gets us a x position of 20.2 meters.